If you've ever seen a 3D printer in action, it's mesmerizing, right? It's like watching this little robot meticulously build something right out of thin air, one tiny layer at a time. It seriously looks like magic. So today, let's pull back that curtain and see what's really going on. We're going to break down the most common kind of 3D printing you'll probably run into. It's a process called Fused Deposition Modeling, or you'll probably just hear everyone call it FDM for short. Now, at its heart, the whole process is actually surprisingly simple. Basically, the machine takes this thin plastic string, we call that a filament, it melts it down, and then it draws the object, one layer at a time. It's literally building it from the ground up. Honestly, the best way to picture it is like a robot piping frosting onto a cake. Seriously, it just builds it up, one super careful layer after another. So this machine isn't just printing, it's constructing. The real question is, how in the world does it pull off this incredible feat? All right, so how does this amazing machine actually do it? What are the key parts that make all this layer-by-layer magic happen? Come on, let's take a peek under the hood. Okay, so you can really think of an FDM printer as a tiny automated assembly line. It all kicks off with the raw material, which sits on the filament spool. From there, it gets pulled in, melted down, and then laid down with incredible precision onto what's called a build plate to create the final object. All right, let's break down the key players here. First up, you've got the filament spool. The easiest way to think of this is like the ink cartridge for your paper printer, but, with plastic. Next, the extruder and the hot end. These guys work together to pull that plastic in and melt it. Then, that molten plastic gets squeezed out through a tiny nozzle, depositing it right onto the build plate, which is basically the foundation for your object. So, what controls all this movement with such insane precision? Well, that's the job of the stepper motors and belts, and they have to be absolutely perfect because even one tiny wrong move can mess up the entire print. It's really this beautiful dance between mechanics and electronics. Okay, so with all these moving parts and this need for crazy precision, you might be thinking, why is this particular method, FDM, so incredibly popular? Especially for students, hobbyists, and startups. Well, the answer really boils down to a few key things that totally opened up this technology to everyone. For starters, FDM printers are super affordable and pretty easy to use. That's what makes them perfect for what we call rapid prototyping. You can have a physical model in your hands in a matter of hours, not days. But like with anything, there are trade-offs. The surface finish can be a little rough, and the final strength of the object, well, that all depends on how well those layers stick together. And that brings us to the classic trade-off, right? It's all about speed versus quality. If you try to print too fast, those layers just don't bond as well, and you end up with a weaker part. But if you slow it down, you get a much stronger, much higher quality result. It's this constant balancing act you have to play. My friend Maya put it perfectly. She said, "So basically, it's like our semester project. Fast karoge, to quality ghat jayegi." And it's so true, isn't it? You can rush to get it done fast, but the quality is definitely gonna take a hit. It's the exact same principle. And really, this gets to one of the most fundamental lessons in all of engineering, doesn't it? It's that constant search for the perfect balance between speed and precision. And this accessibility, it is a total game changer. Just think about it for a second. Students and small startups can now create things like custom prosthetic hands, or prototype lightweight frames for a drone, or even just invent a unique part they need for a project, and they can do it all right from their desk. FDM really gives innovators the power to take a digital idea and turn it into a real physical object, super quickly and affordably. It's the tool that turns what if into, here it is. And I think that's the real takeaway here. This whole idea of building something layer by layer, it isn't just about plastic and machines. It's a metaphor for how we learn, how we create, how we innovate. We do it one piece, one idea, one layer at a time.